Hey guys, Ms. Fearing here. Welcome to Unit 2 Notes 5, Solving Systems Using Any Method. So our learning target for today is I can solve a system using any method, in which case we're going to be talking about either substitution or elimination. So there's a couple things that we can look at when we're trying to decide which form to use or which method to use, whether it's substitution or elimination. So when we want to use substitution is when I have an equation that's already solved for a variable. So I have a y equals or an x equals. If I see a y equals or an x equals, right away I know I'm using substitution. I can use substitution for sure when I'm in slope-intercept form or when it's easy to solve for one of the variables, when it's easy to get a y equals or an x equals. I want to use elimination when I'm already in standard form. Remember, standard form is ax plus by equals c, so your x and your y are on the same side. If you're dealing with opposite signs, so one's a positive and one's a negative, or if you have the same number on the same variable. So looking at example 1 here, I see right away that I have opposite signs. One is positive and one is negative. And I have the same number on the same variable. My y's both have 5s with them. So that to me says I'm going to use elimination for this. So I'm going to go ahead and just add straight down because of the fact that my variables already eliminate, my 5s already eliminate. So I'm going to end up with 5x equals, don't forget to do 7 plus 13. And then solve for x. I know x is going to equal 4. And that extra step then of taking that and plugging it back in. So pick one of your original equations. I'm going to pick 3x minus 5y equals 7. And now I'm going to plug the 4 in for the x. So I'm kind of going to use substitution there. Substitute the 4 in for the thing I know. And I'm going to go ahead and solve. So I get 12 minus 5y equals 7 minus 12. Divide by negative 5. So y is going to be 1. So my final answer is going to be 4, 1. Number 2 we're looking at here. And I have one of my equations already in slope-intercept form, or it's solved for a variable. So that to me screams substitution. So I'm going to use substitution on this. I know that y equals 2x minus 10. So that's going to go in for that y on that first equation. So I'm going to have 5x plus 3 times 2x minus 10 equals 3. And I'm just going to solve for x. So 5x plus 6x minus 30 equals 3. I get 11x minus 30 equals 3. Keep solving here. I had 11x equals 33, so I know that x is going to equal 3. And then I'm going to take that and plug it back in. In this situation, I'm going to plug it into the second equation because it's easier. So I'm going to get y equals 2 times 3 minus 10. So y equals 6 minus 10, which means y is going to be negative 4. So my answer is going to be 3, negative 4. So number 3 here, I see this one as having the same number in front of a variable, as well as that number being one positive and one negative. So to me, this screams elimination. But if you saw this and you said, well, I want to solve that first equation there for y and then use substitution because I like that better, you would have got the same answer. So I'm going to go ahead and I'm going to use elimination on this one. So I just have to rewrite it so that I have the x and y on top of each other. So the x is on top of each other and the y. So I'm going to rewrite the top equation so that it's 3x plus y equals 24. And now I can go ahead and I can add straight down. So I get 8x, those cancel, equal 32. Solve for x. I get x equals 4. And now I can plug that back in. I'm going to go to that top equation again. And I'm going to substitute the 4 in for x. So I get 3 times 4 equals 24. Oops, that should have been a plus sign right there. So y plus 12 equals 24. So I'm going to get y equal to 12. So my final answer would have been 4, 12. So again, if you decided a substitution was better there, you still should have got the same answer. For number 4, I don't have anything that has a variable equal, so I don't have a y equals or an x equals. I also don't have something that's going to be easy to solve for a y equals or an x equals. So since substitution isn't going to work on this one, I have to use elimination. So I'm going to ask you to pause the video and try this problem out, see what you end up with, and then check your answer. So here's what I ended up with for number 4. I got 2, 2 as my solution. So in the beginning, I had to multiply both equations by a number because I needed these two to be the same number, but one positive and one negative. So I did the flip-flop of timesing the top by the 5 and the bottom by the 3. Sorry, this should have been a positive 3 that I did. So once you got those two equations, all you had to do is continue to solve. If you have any questions on this one, please pause the video and then come chat with me. So we're going to go ahead and look at 5 and 6. I'm going to try to walk you through how I chose the method I did, and then I'm going to ask that you go try 5 and 6 on your own, and then come back and check your answers. So number 5, I have a y equals. Remember, if I have a y equals, that screams to me that I should be using substitution. So in number 5, I would suggest using substitution. If you wanted to put it in standard form and use elimination, you could. It would still get you the same answer. It's just a little bit more work. For number 6, I don't have a y equals or an x equals equation, and neither one of these look like they're going to be really easy to solve for y or x. So by process of elimination, I know that I'm going to have to use elimination on this problem. So like I said, I want you to go ahead and try 5 and 6 on your note sheets. This is just some extra practice for you. You've done substitution and elimination. And then come back and check and make sure that you got the same answer. So here's the two answers I came up with. For number 5, I got -3, -1. And then for number 6, I got 4, 1. So if you got anything different, please check your work with what I have here. See if you can find your mistake. If not, come chat with me and see if we can work through it together. Number 7, Deshawn and Shania are selling flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and bags of daffodil bulbs. Deshawn sold 10 bags of windflower bulbs and 12 bags of daffodil bulbs for a total of $380. Shania sold 6 bags of windflower bulbs and 8 bags of daffodil bulbs for a total of $244. What is the cost of 1 bag of windflower bulbs and 1 bag of daffodil bulbs? So I'm going to go ahead and I'm going to say my windflower are my x's and my daffodil are going to be my y. So we're going to write Deshawn's equation first. So he sold 10 bags of windflower and tells me to add 12 bags of daffodil for a total of $380. Shania then sold 6 bags of windflower and 8 bags of daffodil for a total of $244. So because neither one of these are an x equals or a y equals, and it's not going to be easy to solve either of these for an x or a y, I'm going to go ahead and do elimination for this. So we're going to eliminate. Neither one of these are going to cancel right now, and I can't multiply 6 by anything to make it look like 10 or 8 by anything to make it look by 12. So we're going to have to kind of go ahead and do the flip-flop. So I'm going to multiply this one by a 6 and the second one by a 10. The issue I would have right now is they would both be positive, so I'm going to go ahead and I'm going to make this 10 a negative. Whoop. Sorry about that. So I'm going to go ahead and I'm going to make this 10 negative right here. And that way one will be positive and one will be negative. So my new equations I'm going to end up with is 60x plus 72y is going to equal 2,280. And the second one I'll get negative 60x minus 80y is going to equal negative 2,440. Now I'm able to add straight down. I get negative 8y is going to equal negative 160. solve for y. So y is going to equal 20. And then I can take that and I can plug that back into one of my original equations. So I'm going to go into the top one, 10x plus 12. Since y is 20, I can plug that in. And now I just have to solve. Subtract the 240. So I'm going to get 10x equal to 140, divide by 10. So x is going to equal 14. So remember, a problem with words needs an answer with words. So my y was my daffodil. So my daffodil bags or bulbs are going to cost $20. And my windflower are going to cost me $14. So last problem here, number 8 is very similar to number 7. So at a store, toothbrushes cost X dollars and bars of soap cost Y. So I know that my toothbrush is going to be my X and my soap is going to be my Y. So we're going to write an equation right away. One customer bought 2 toothbrushes and 1 bar of soap for $11. Another customer bought 6 toothbrushes and 5 bars of soap for $38. We want to find out how much each toothbrush costs and how much each bar of soap costs. So in this situation, I don't have a y equals, but that first equation, I can easily solve for y. I can get y alone by just subtracting 2x. So I'm going to subtract 2x from here and subtract 2x from here. So my new equation is going to be y equals to negative 2x plus 11. So I can take that and I'm going to plug that in for the y in my second equation. So I'm going to end up with 6x plus 5 times negative 2x plus 11 equals 38. So now we're going to go ahead and solve. So I get a negative 4x plus 55 equals 38 minus 55. Negative 4x is going to equal a negative 17. So x is going to equal $4.25. So I can take that and I can plug that back in now to this y equals negative 2 times 4.25 plus 11. So I'm going to get y equals negative 8.50 plus 11. So y is going to equal $2.50. So now a problem with words needs an answer with words. I know that my toothbrush is going to cost me $4.25, and my soap is going to cost me $2.50.